Malonic ester synthesis is a way to easily make what are called substituted acetic acids. Malonic acid itself has that molecular structure, and of course it's a dicarboxylic acid, and we can prepare easily the diethyl ester, which would be called diethyl malonate. For an overall reaction, we could use any ester, R, or ethyl in this case, and we can change that to R just to generalize. Upon treatment of the malonate with a suitable base like ethoxide, we get conversion to an enolate, and the enolate can be alkylated with our suitable halide. And following alkylation, if we wanted to, we could do another alkylation and put two groups on the alpha carbon. Once we're done alkylating, the third step is treatment with water and acid and mild heating. That does two things. It hydrolyzes both esters to the carboxylic acid, and the resulting beta diacid is susceptible to spontaneous decarboxylation to provide the substituted acetic acid, and by substituted, that group has been substituted for one of the H's of acetic acid. And of course that group comes from the R group of our halide. Mechanistically abbreviated now, treatment of base forms a resonance stabilized enolate. And the enolate subsequently can displace chloride from benzyl chloride. And at that point, hydrolysis with acid and water is going to hydrolyze both esters into their corresponding acids, and we should already know that mechanism. If not, good time for going and reviewing that. And thus we arrive at a beta diacid, and this is prone to decarboxylation with mild heating, and again it's going to be this H will end up on that carbon. And I arbitrarily just chose to lose that as CO2. And this H is again now on that carbon. And that's called a substituted acetic acid again.